So I'm going to take another look at this video from Exploring the Plane. Now you might recognize this. This came out last year. It had already been debunked a number of ways by the globe community. But what I want to do is take a look and do some angular size measurements of a few of the objects in this photograph. And we're going to see, do they match the flat Earth or the globe perspective view? Now, the flat Earth community has complained for a long time that Earth curvature calculations don't take perspective or angular size measurements into consideration. So I think there was a certain irony that when the globe community applied angular size measurements to this photograph, suddenly the flat earthers didn't think that this was something that should be done. Now the photo on the top is looking to the north and the photo on the bottom is looking to the west across the water to the Isle of Man. And I think it's important to include this into the debate because this photograph was taken in the same area but on a different day. Now this video will be part one to see if angular size measurements match the flat Earth perspective view. Next, I'll release part two to see if those measurements match the globe perspective view. Now, flat earthers need to understand that since they have defined their world as a place where mean sea level is flat and level water, then they have described a physical model that we can use to make measurements from. Now, since the Earth is flat and we're talking about long distances, we can use a right triangle like this one here, and we can use this formula right here to make accurate angular size calculations. Now, Exploring the Plane did a very good job of supplying accurate data for his observations. So here he has a target distance of 89.5 miles. Now first I want to make an angular size calculation for Snaefell, and it is easily identified because you can just make out a small building and a large antenna on the top of this peak. Now it was quite easy for me to find the exact location of Exploring the Plane on Google Earth, and Snaefell is a little bit farther. I got 89.65 miles. And you can see down here, Snaefell has an elevation of 2,037 feet. So again, we have 89.65 miles in distance. Over here, I have converted feet into 0.3857 miles. And if you're wondering what these three dots are, I'm doing these calculations on a calculator, and this tells you that I have not rounded the answer off to the fourth decimal place. So when I do the calculation, Snaefell has an angular size of 0.247 degrees. So I'm going to round this off to 0.25 degrees. And that's how big Snaefell should appear if the Earth was flat. So I'm going to compare Snaefell to these wind turbines, and this is the west of Duden Sands wind farm. Now this is from Wikipedia, and on this map you can see a rough location of it between Blackpool here and the Isle of Man. But I found a better map. This was from KISS Orca, which includes latitude and longitude lines. And next I added this map to Google Earth, and I was able to correctly align it using those longitude and latitude lines. Now from Exploring the Plane, I have two lines running to Snaefell and North Barule. And you can see that they are on the southern edge of this wind farm. So in the photograph, most of the wind turbines are going to be to the right. And also the distance from Exploring the Plane to the front edge of this wind farm is about 42 miles. Now this photo shows that my alignment is correct because we see that most of the wind turbines are over here to the right of North Barule. So on the left over here, this is from Wikipedia, rotodiameter 120 meters, and this is a Siemens SWT 3.6. Now this is from another website, so we have Siemens model SWT 3.6-120. We got a rotor diameter of 120 meters and a rotor hub height of 90 meters. Now this is a graphic that I drew. So we have a hub height of 90 meters and we have a rotor radius of 60 meters. And that gives us a total of 150 meters in height or 492 feet. So we have a distance of 42 miles for the wind turbines and a height in miles of 0.09375. And that gives us an angular size of 0.128 degrees. I'm going to round that off to 0.13 degrees, and that would be represented by this line right here, because here we have a turbine with the blade straight up, and here we have another turbine with the blade almost straight up. Now you can see that the flat earth is already in trouble because Snaefell here is actually less in angular size than the wind turbines, but it should be somewhere up here at almost twice the height in angular size. But let's take a look at Blackpool Tower over here so we have one more angular size measurement. So Blackpool Tower is 24.6 miles away from exploring the plain. And it has a height of 518 feet. Now this is from Google Earth, and you can see that the tower is right on the waterfront. And one thing I noticed was this building over here, there is a small tower on top of it. Now this is the other side of Blackpool Tower on Google Earth. So here's a blow-up of Blackpool Tower, and we can see that little tower right here. Now here's a nice photograph I found of Blackpool Tower taken from the Ferris wheel. So that means that the eye level is going to be somewhere up in this area. And that also means that we won't have the foreshortening distortions of a photograph that was taken down at ground level. So I'm going to use this as the height of Blackpool Tower, and this line here, I tried to align it. This would be the front of Blackpool Tower, so this would be about the equivalent street level in that area. Next, I scaled this photograph so the top of Blackpool Tower align, and then the top of these little towers align, so this should be the approximate street level. So for our angular size calculation, we have 24.6 miles in distance, and converting feet to miles, we get 0.0981, and that gives us an angular size of 0.228 degrees. I'm going to round that off to 0.23 degrees. So how does this compare to the wind turbines? So again, this line here goes across the top of this turbine and across the top of this turbine. This is 0.13 degrees, so I have scaled this angular size ruler to that dimension. Next, I copy and pasted the ruler over here, aligning 0 with street level, and we get a measurement of about 0.24 degrees, which is very close to the calculation of 0.23 degrees. Now keep in mind that all of these are estimations, but at the same time, I think it shows that these calculations are an accurate representation of what we see in this photograph. This is a copy and paste of that ruler over here. This is a contour line that I drew from the top of the peaks down here. So if the Earth was flat, Snaefell would be somewhere up in this area, and this would be the Isle of Man. Not even close to what we see. So I think we have more solid evidence that these observations do not match the flat Earth model. And of course, this is not surprising when you use some critical thinking as you look at the evidence. Now, this is from another flat earther, P1000 Coolpix. She shot this from Blackpool. So, of course, this is the Isle of Man in the background here. So let's take a look at her video. Now, this is Snaefell. You can just make out that building and the antenna on the top. We do have a very thin inferior mirage. But look at this, we have turbines with the blades going into the water. Over here, you can only see the top of the blades coming out of the water. How does anyone look at this and think that this is what they would expect to see on a flat Earth? My next video will be part 2, where we take a look at the globe perspective view, and we'll see if those angular size measurements match the globe model.